Today we'll be looking at the today's LeetCode daily problem. So I will just start with the problem statement. I have already noted it down. So what we are given are two arrays, two sorted arrays, okay? And we need to find the kth smallest product which can be formed using one of the elements from one array and the other from the other array, okay? Now so just let me erase this stuff. Okay, so we are given two arrays. Okay, now it's important to look at the constraints. So I have already noted down the constraints. So you can see we have n comma m. First of all, both of the arrays could be not equal size, right? So they could have their own size. So n and m, we have n and m less than equal to 5 into 10 to the power 4, okay, which is the size of the array that we can have. The elements in the array can range from minus 10 to the power 5 to plus 10 to the power 5, and the k is obviously in the range so that you can always find a smallest product, kth smallest product, right? So like how many products do we have if we are given two arrays of size n and m, right? So we have n cross m products, right? So one very brute force approach is that we can just store all those products in some array or in some vector, and then we can just sort it out and we can give uh, the kth value in that vector, right? So that will turn out to be a time complexity of o of order of n square into log k, and k can go up to n into m, which is again an order of n square, right? So obviously this is not the very best solution, right? So and that's why we have to think of a more optimal way to solve this question, right? Okay, now also we see that the two arrays are sorted, right? And if we try to do some clever thing like, that what if only the first values, like if they are sorted, the very first values, if I take, they might be the smallest. Now they might be the smallest, they cannot always be the smallest, right? Because we have negative numbers as well in the array, we have positive numbers as well in the array, right? So just imagine if it was 5, very first element a0 is minus 5 and b0 is also minus 5. Now the product of these two will turn out to be 25, which is the plus 25. And let's say we had 0 somewhere in one of the arrays, so the product was supposed to, the lesser product was supposed to be 0, right? That's why this idea doesn't work, right? So also, like, there is another idea that the smallest product, if I have to just ask you, what is the smallest product? Now this idea is pretty clever, that smallest is always the minimum of a0 b0. Either you combine a0 with the first and last element of the other array, right? But this is like, this doesn't help you find the actual answer, right? You might think that, okay, we take the smallest value and then we remove the a's, like whichever combination is giving us the smaller, right? And we, let's say if a0 and b0 give us the smallest product, then we go ahead and removed a0 and b0, right? But in that case it will not work as well, because it might be possible that we have a0 also combining with some other b and giving us a product which was actually coming as the kth product, right? So if you just talk about the very first smallest k products, it might be possible that a0 might be contributing more than one number of times, right? So we cannot just remove that element. So I hope that makes sense. So okay, Now after this you start making some statements. So I have one statement here. Let's say if the kth smallest product is less than equal to some value x. Okay, so now this x is like we are trying to make some statement, trying to see like what could work and what could not. Okay, then is it also okay to tell that our kth smallest product is less than equal to x plus something? Okay, now two things to actually notice here. So very first thing is that let's assume that the kth smallest product was less than equal to some value 20, right? So it is also less than equal to 25 as well, right? So this makes sense. Okay, now there is an inequality sign, right? So in our statement we are saying less than equal to, we are not saying if k the smallest product is equal to x. Okay, and then we are not saying that if k the smallest product is equal to x, then k the small product is also equal to, that doesn't make sense. So that's why the inequality sign, which is less than equal to x, is very much important here. And that's from where we start getting the ideas of binary search. Okay, now the thing is, okay, that this statement makes sense. We are able to come up with a binary search now, right? So what is very first thing is what is our search space? So search space is basically what is our the highest that we can go and the lowest that we can go, right? So in this array, if you see, the highest product that we can have is 10 to the power 10, because the highest value of ai can go to 10 to the power 5, and the bj also can go to 10 to the power 5. So we have the highest value as 10 to the power 10, and the smallest in a similar fashion is going to be minus 10 to the power 10. Okay, this is our search space. Okay, now let's say you assume some value x to be your kth smallest product. This x is not the actual kth smallest product. This k is basically some value that you are assuming which is less than equal to x, and somehow you are able to find the count of it. Okay, so count ai into aj less than equal to x. So first you assume some x, right? And then you're trying to find how many values is less than equal to x, how many products after combining, sorry, this should be bj. So how many products after you take one element from a and one element from b, how many products will be less than equal to x? Okay, so it's again simple to do it, right? We can just take two loops and we can find it in n cross m time, right? But we don't want to do that, right? Because again the complexity for our predicate function becomes order of n square, right? So we need to be smart here, right? So let's try to do some math. So we want to find a into bj. We want to find how many values less than is giving us the product less than equal to x, right? After combining two elements from these arrays, right? So first we have fixated the x because we have made an assumption, or you can say we have just fixated the x, very first thing. Now you also need to fixate one of these values in order to count number of products which are less than equal to x. Okay, how do we do that? So let's fixate ai. Okay, so we go and we divide it by bj, or let's do one thing. We can just fixate ai. So we just divide it by, so bj is coming out to be x divided by ai. Okay, so what does this equation mean? This means that if our bj is sorted, right? So you can just imagine there is some, is there a way to find that jth index which is less than equal to a in a sorted array? Yes, there is. We have lower bound and upper bound, right? We can directly do an upper bound on this value, right? And we can find that. Now imagine what this value should be. Should this be a floor? Because all of this value is an integer, right? All of these values is an integer. Let's say one, after we divide, we got a value like 4.89, right? So you would want to only stop right at 4. You'll stop your counting at 4. You'll not count anything greater than 4. Like 5 will never give you 5 into AI will give you a value which is greater than x, right? So understand this. And right now we just assume that everything is positive when we are doing this, because if you don't assume that, then it will be very little harder to go into different cases, but we will go into different cases as well, right? So right now this is a case when AI is greater than 0. Okay, then you can do you can actually add those many, basically what you can do is count plus equals to j, where j is the upper bound index on x divided by I floor value. Okay, now here you should also understand that x is also greater than 0, right? But if you do a floor value, like we have a floor function, and if you do floor x divided by ai, okay, like convert this into a double value, like you can typecast this with a double, okay, and then you take a floor value, and then you do a upper bound, then it is fine to do this, right? We don't need to make another case like where x is negative and if x is positive, right? You don't need to do that. You can use the floor value that we have in C++ to find this. Okay, now what happens when AI is negative? Now in our maths, right, when we were trying to solve inequality equations, right? So what happens if you take this, basically if you take this thing and if I write it here, right, ai into vj is less than equal to x, and what if I multiply this with negative both sides, then it becomes greater than equal to x, right? This is what it becomes. And now when you take this side right, so you have x divided by ai, right? And here you need to take a ceil value. I hope this would make sense now, because let's say now you have a value like 2.7 or something, right? So you would not want to take a value which is 2, right? You would want to take the value which is 3, right? And this very first value greater than equal to 3 you would want to find, right? And again, this should be, if you are doing it in C++, you have to do it using the ceil method, and you have to pass the double value, right? You have to pass the double value. There are other ways as well to do this, right? Okay, one second. So there are other ways to do it as well, but I found this to be the simplest way and the least confusing way, because again, if you try to branch out your possibilities and then you try to do if else and if else, it becomes a very big implementation. Okay, so here we need to find ceil value x divided by I, bj greater than x divided by I. How we can do this? We can find the lower bound. We can find the lower bound on the B array on this value, okay, and you will get that index, right? Now all the index from back, so let's say if you found lower bound index was here, so all this value from back should be added to your count, right? Here, if you found the upper bound, all the values from first should be added to your answer, right? Because we are calculating all the values which are greater than, right, greater than this value, and here we are trying to find all the values, one second, less than, right? So less than will always be before index, right? And this should be after this index. So if you take this, right? So these are very important observations. When you are trying to implement, you have to be very, very careful if you're trying to implement in this way, right? I'll show you my implementation as well, which is pretty tidy, I say. Okay. Now there is a third case as well. What if AI is equal to 0, right? Now let's get back to the same equation. Okay. I'm not sure how to, so let's copy this and let's paste it over here. Okay. So yeah, now what if AI is equal to 0? What will you add into your count? That's I think pretty simple. So if AI is 0, if X is positive, right, then you cannot add anything. If X is equal to 30, you cannot add, or anything. If X is not equal to 0, you cannot add anything. So if AI is equal to 0, you have to check if X is equal to 0, then you can add everything. You can add everything from the B array, right? Because anything you take from B, it will always give you 0. So this was an easy calculation, this case, right? Now what else, right? Now after this we can start actually implementing stuff, right? So let me show you my implementation. It's pretty clean, right? So you can see, first of all, I have created a floor div and a seal div methods, okay, so that I don't have to write it again and again. Okay, one more thing here. Okay, let's go back to the iPad screen. Okay, so how do we usually do our binary search? So we have our low as -1e10, right? Our high as 1e10, right? And our X is actually the mid, which will be low plus high divided by 2, right? And guys, we be very careful while implementing this, because the answer is in long and you might get overflow issues, right? So don't write this. I would recommend write, okay, so I would recommend write high minus low divided by 2 plus low, I guess. Yeah, this should also work, right? And then you do this count. So there is a count method which gives you number of products, or you can say count of products whose value is less than equal to X, right? Whose value, so let's write it down. Count X is giving us number of products, number of products less than equal to X from AI BJ. Okay, so this is an important thing. So this is what count of X is going to return you. Okay, now when do you say, how do you decide which way to go, right? So if let's say this value is equal to k, right? This count value is actually equal to k, then we are good to go, right? If this value is less than k, then we are not good to go, right? We had to basically increase our X, right? Because we are not able to fit k numbers, right? If it is greater than k, then also it is fine, right? Because in this case, we'll try to reduce our the high pointer to find the lowest one, right? Because the very first statement that we made, right? So kth smallest product is less than equal to x, right? So let's say if this was x, then we have x plus 1, we have x plus 2, right? So if kth smallest product was less than equal to x plus 2, right? You would not take the x plus 2, right? You have to find the smallest one, right? So you would reduce your high pointer and you would try to find the, basically, if in terms of a predicate function, all of this before is false and all of this after is true, right? So that's how our predicate function returns true value and false value. So we need to find this very first true. Okay, and where do you find this very first true, or where do you find the false values? When you have values greater than k. So that's how you have to, that's how much you actually, first of all, you have to think in order to implement this. After that, the predicate function implementation in itself is a very big thing to do it properly, because I have gotten so many wrong answers, right? So you can see, let's go here. So I have defined my low pointer and I have a high pointer, right? So this is the search space, right? And then I have my answer and I just do this as I showed you. Now count of product less than equal to x is greater than k, greater than equal to k. Okay, then I'll say that this is also one of the answer. This x is also possible. Then you just reduce your high, right? And this is one of the answer, and then you just store it. Now it's very important ki how do we actually write this function? Count of product less than equal to x, right? So what I have done, first our x is fixed, then I have to fixate one of the a or b, right? So you fixate a, then you find that jth index, which would, as we did our maths here, right? So we fixate ai and then we try to find a point on bj that we could take. So basically this is also like, if you try to think it in terms of positive values. So let's say your product x was 15, right? And right now your ai is 3. Okay, then this turns out to be what? Bj less than equal to 15 divided by 3, which is less than equal to 5. You would not take values which are 6. And how you can find that? You can simply find that by doing a binary search on the b array, which is nothing but the upper bound and lower bound, which I am doing. Okay, so very first thing, so let's try to see the when ai is equal to 0. So this is that case. So I've taken, if x is greater than equal to 0, then add everything from bth array in my count. Okay, this function is doing nothing but it's just counting, is returning the count of products less than equal to x. Okay, now if ai is negative, right? If ai is negative, we saw this, right? So here, yeah, if ai is negative, we have to take the ceil value and then we have to find the less than equal to value, right? One second, not less than equal to, here when ceil, then we have to find the greater than equal to this value, the value that we are getting, right? So this can be found out using lower bound. Lower bound gives you the very first index, right? So guys, just imagine this. Okay, we have a lot of values, right? We have, like, let's say this value turns out to be equal to 5. Okay, and we have 5 5 5. This is sorted, right? So 1 2, you can imagine this is b array. So you need to find this first value and you need to take everything which is after this. Okay, so how do you find the very first value greater than equal to? This is directly given by our lower bound. Okay, and here we are taking all the elements, right? we are not taking the length, we are taking all the elements, right, from the n minus index, right? N being the size of the bth array, right? Okay, now when ai is positive, this is we are taking upper bound, and since we want this is the value which is less than equal to, so we are taking the first all index value, right? Okay, I think once you go through this code, this will be very much helpful. Okay, so I think, yeah, after that you get the count, and then it's pretty much it. You don't have to uh, I don't think there is anything else to talk about. Yeah, so thank you everyone. Let me know if you have any doubts. You can ping that in comment. I'll try to take it from there. Thank you so much.